Hello everyone, welcome back to our channel Gyan Kalyan. I am going to continue the chapter Carbon and its compounds. In the previous video, I have discussed about the formation of the molecules, that is the hydrogen molecule and the oxygen molecule, and we have seen the formation of the bonds, single bond in hydrogen molecule and double bond in oxygen molecule. So in this video, I will continue with that. इन द प्रीवियस वीडियो हमने देखा था कि कैसे दो हाइड्रोजन एटॉम्स अपने एक एक इलेक्ट्रॉन को शेयर करके एक सिंगल बॉन्ड बनाते हैं और उस बॉन्ड को हम कोवेलेंट बॉन्ड के नाम से जानते हैं, और कैसे दो ऑक्सीजन एटॉम्स अपने दो इलेक्ट्रॉन्स शेयर करके एक डबल बॉन्ड बनाते हैं. सो these two bonds are the covalent bonds because sharing of electrons is taking place. So now we will see in the case of nitrogen atoms how they will share their electrons to form the bond. So nitrogen का atomic number 7 होता है, so electronic configuration will be 2,5. इसका मतलब नाइट्रोजन के outermost shell में 5 electrons present होंगे. तो 2 nitrogen atoms will share their 3 electrons each to form a bond. Okay, now let us see how it takes place. So this is nitrogen atom and there are 5 electrons present in the outermost shell. Sorry for the diagram. And again we have another nitrogen atom with 5 electrons in its outermost shell. So what will happen? Both of these nitrogen atoms, they will share 3 electrons each. दोनों ही अपने 3 electrons share करेंगे और they will form एक triple bond. They will form a triple bond and we represent that triple bond as 3 lines. Okay, 1, 2, 3. So this is one nitrogen. This is another one. So this is the triple bond because 3 electrons have been shared. Okay, I think this is clear. So now we will see the formation of a simple carbon compound, that is methane. So methane को सबसे simplest carbon compound के नाम से जाना जाता है. So methane's formula, methane का formula है CH4, मतलब एक carbon atom और 4 hydrogen atoms. So let us see how it is formed. Hydrogen has a valency of 1. Okay, and carbon is tetravalent. So in order to achieve noble gas configuration, carbon shares these 4 electrons with 4 atoms of hydrogen. So let us see the formation. So there is a carbon atom, a single carbon atom. So it has 4 electrons in its outermost shell. तो एक carbon atom है और उसके 4 electrons बाहर उसके सबसे बाहर वाले शेल में मौजूद हैं. So what will happen? It will share each of its 4 electrons with 4 hydrogen atoms. Okay, so hydrogen has 1 electron each in its outermost shell. So this is the way in which they will form bond. Okay, something like this, single bond. आप देख सकते हैं कि ये 4 bonds ही single bond है. So this is the bonding in CH4 जिसका नाम है मीथेन. मीथेन में इस तरीके से bonding होती है. So you can see that 1 electron each is being shared. So this is the formation of methane molecule. I hope आपको समझ में आया. Now see, the bonds which are formed by the sharing of an electron pair between 2 atoms are known as covalent bonds. तो जो भी bonds electron के share करने पर बने थे उन्हें हम covalent bond के नाम से जानते हैं. तो these bonds are strong bonds within the molecule, but their intermolecular forces between them are very small. Intermolecular forces is simply the force which is between the neighboring molecules. Okay, and this gives rise to the low melting and boiling points of these compounds. क्योंकि उनके intermolecular forces बहुत ही कम होते हैं, इसीलिए the melting points and the boiling points of covalent compounds are low. Since the electrons are shared between the atoms and no charged particles are formed, the electrons are being shared. Electrons को दोनों ही atoms share कर रहे हैं, ना कि एक दूसरे को completely दे रहे हैं. So that's why they are not forming any kind of charged particles. As we have seen in the case of the ionic bonds, in the covalent bonds, the electrons are being shared, so no charged particles are formed. So those covalent compounds are generally poor conductors of electricity. Why? Due to the absence of charged particles. So next we will see the occurrence of carbon. Carbon किस states में present है और वो किस state में पाया जाता है? Let us see that. Carbon occurs in free state as well as combined state. Okay, carbon is found in two states. In the free state, carbon occurs in nature mainly in two forms. So free state पे carbon दो forms में मिलता है, diamond and graphite. In the combined state, carbon occurs in nature in the form of compounds such as carbon dioxide in air, carbonates like chalk, marble, fossil fuels, coal, petroleum and natural gas, organic compounds like carbohydrates, fats and proteins, and wood, cotton and wool. So these are the forms in which carbon is found, both in the free state and the combined state. Okay. So carbon free state में diamond और graphite के अलावा Buckminsterfullerene के form में भी पाया जाता है. Okay. And most of the carbon is known to occur in the combined state. Okay, it is found to be occurring in the form of compounds such as carbon dioxide, carbonates, etc. Next is allotropes of carbon. So this is an important topic of this chapter, allotropes of carbon. So the various physical forms in which an element can exist are called allotropes of the element. So allotropes means those physical forms. There are various physical forms of the same element. Okay, the same element can exist in various physical forms. So those are the allotropes of the element. So जैसे कि carbon, diamond, graphite, Buckminsterfullerene, इन तीन physical forms में पाया जाता है, exist करता है. तो definitely those are the allotropes of carbon. The same element, but the physical forms are different. So let us see what are those allotropes. Let us see. The first one is diamond. Diamond is a colorless, transparent substance having extraordinary brilliance. We all know that. It is the hardest substance known. So diamond is the hardest substance known. I hope कि आपने ये सुना होगा. It does not conduct electricity. So diamond cannot conduct electricity. A diamond crystal is a giant molecule of carbon atoms. So it is a giant molecule, a very big molecule of giant carbon atoms. Each carbon atom is bonded to 4 other carbon atoms, forming a rigid 3-dimensional structure. So एक carbon atom 4 carbon atoms के साथ bond form करके एक 3-dimensional structure बनाता है. That is the structure of diamond. Okay. So experimentally हम कैसे ये कह सकते हैं कि diamond में सिर्फ carbon atoms ही present है? How can you say that? So what is performed is if you burn diamond, so what will happen? That only carbon dioxide gas is formed and nothing is left behind. So this is the proof that diamond is made up of carbon only. So in the diagram given below, आप देख सकते हैं कि how the carbon bonds are formed. कैसे एक carbon और दूसरे 4 carbons के साथ bond form करके एक regular tetrahedron shape form करेगा. Okay. So the structure is the reason why carbon is a very hard substance. Okay, the carbon atoms are powerfully bonded to one another by a network of covalent bonds. So this gives the rigid three-dimensional structure to the carbon, and it is very useful in various purposes, okay, like drilling, oil wells. So for making glass cutters, diamonds are used. Again, diamond has a very high melting point, but it is a non-conductor of electricity. Why? Because the carbon atoms are attached. One carbon atom is attached to another 4 carbon atoms, so no free electrons are present. Okay, the carbon is bonded with another 4 carbon, and no valence, and all the 4 valence electrons of the carbon are used to form the bond, so no free electrons are left over there, so the carbon cannot conduct electricity. So that is the reason why diamond is a non-conductor of electricity. Next is graphite. It is another allotrope of carbon. So let us see how it is. Graphite is a greyish black opaque substance. It is lighter than diamond and is soft and slippery to touch. So graphite is almost opposite to diamond in few cases, like it is lighter than diamond, it is not as hard as diamond, and it is soft and slippery to touch. Again, graphite conducts electricity. Graphite crystal consists of layers of carbon atoms or sheets of carbon atoms. Okay, there are, you can see in the diagram, there are kind of layers of carbon atoms, and each carbon atom in a graphite layer is joined to other 3 carbon atoms. So diamond में क्या होता था कि एक carbon atom gets bonded to 4 other carbon atoms, but in case of graphite एक carbon atom 3 carbon atom के साथ bond form करके एक graphite layer बनाएगा. So they are bonded by strong covalent bonds to form flat hexagonal rings. Hexagonal rings in case of graphite. So again, to check the presence of carbon atoms, only carbon atoms in graphite, हम क्या कर सकते हैं, graphite को फिर से burn करके देख सकते हैं कि सिर्फ कार्बन डाइऑक्साइड गैस ही फॉर्म होगा और कुछ भी कंपाउंड फॉर्म नहीं होगा. So this is the experimental proof of the presence of only carbon atoms in graphite. So you can see in the diagram that the various layers of the carbon atoms in graphite are quite far apart. They are not so close to each other, they are far apart, and that is the reason that no covalent bonds can exist. They are bonded by weak van der Waals forces, and that's why the layers kind of slide over one another. Due to the sheet-like structure the graphite has, it is comparatively soft substance. Okay, and again graphite is a good conductor of electricity. So हमने देखा कि graphite एक good conductor of electricity है. It can conduct electricity. Now let us see how. So graphite में एक कार्बन सिर्फ 3 ही कार्बन के साथ बॉन्ड फॉर्म करता है, तो उसके 3 ही वैलेंस इलेक्ट्रॉन्स शेयर होते हैं. द 4th वैलेंस इलेक्ट्रॉन remains that way. So due to that presence of that free electron in graphite, it can conduct electricity. Okay, in diamond एक भी वैलेंस इलेक्ट्रॉन फ्री नहीं था, चारों के चारों बॉन्ड फॉर्मेशन में यूज़ हो गए. लेकिन ग्रेफाइट में सिर्फ 3 ही कार्बन के साथ बॉन्ड फॉर्म करने की वजह से 3 वैलेंस इलेक्ट्रॉन्स का इस्तेमाल किया गया, बाकी एक इलेक्ट्रॉन रह गया. सो दैट इज़ द फ्री इलेक्ट्रॉन विच इज़ प्रेजेंट, एंड दैट ड्यू टू दैट द ग्रेफाइट conduct electricity. So the third allotrope of carbon is Buckminsterfullerene. Buckminsterfullerene is an allotrope of carbon containing clusters of 60 carbon atoms joined together to form spherical molecules. So this is a new allotrope, Buckminsterfullerene, और Buckminsterfullerene में total 60 carbon atoms join together to form spherical molecule. It mostly looks like a football. You can see in the diagram how the carbon is joined with the other to form a spherical molecule. Buckminsterfullerene is a football shaped spherical molecule in which carbon atoms are arranged in interlocking hexagonal and pentagonal rings of carbon atoms. There are 20 hexagons and 12 pentagons of carbon atoms in one molecule of Buckminsterfullerene. It is a dark solid at room temperature, neither soft nor very hard. So Buckminsterfullerene कार्बन और सॉरी डायमंड और ग्रेफाइट से बहुत ही अलग है, क्योंकि डायमंड और ग्रेफाइट आर द एंडलेस नेटवर्क ऑफ कार्बन में बी प्रेजेंट इन देम, बट Buckminsterfullerene में सिर्फ 60 कार्बन एटॉम्स ही प्रेजेंट होते हैं. सो इट इज़ अ वेरी स्मॉल मॉलिक्यूल and it is different from both of them. So here it looks like a football. It has a football like structure. So there are 20 hexagons and 12 pentagons of carbon atoms in one molecule of Buckminsterfullerene. So this is a very important point. Okay. Again, you can check whether a Buckminsterfullerene has only carbon atoms by burning it, and you will see only the formation of carbon dioxide, and that proves that it contains only carbon atom. So this was about the allotropes of carbon. If you have any doubt or any question, please write in the comment box. Thank you for watching.